Hello everybody. So today I'm going to show you how to do specific heat. And so here's the specific heat equation. Q equals mc delta T. Q stands for heat, which is either going to be given to you in units of joules or the abbreviation J. M stands for mass, which is going to be in grams. C stands for specific heat, which is going to have the units joules per gram degree Celsius. And then delta T is going to be the change in temperature, which is going to have units of degrees Celsius. So if you are solving for heat, you are doing Q equals mass times specific heat times the change in temperature. If you are solving for mass, I've rearranged the equation. So you're doing Q, which is the heat, divided by specific heat in delta T. If you're solving for specific heat, you're doing C equals Q divided by mass times change in temperature. And then if you're solving for temperature, you're doing Q divided by mass times specific heat. So this is my general page here for how to solve for heat, mass, specific heat, and then the change in temperature, and then what all of the variables represent. So I'm going to do a couple problems with you so that you know what they're going to look like. So the first one, how much heat will 235 grams of water from 25 degrees Celsius to 100 degrees Celsius? So I'm solving for heat because it's asking me how much heat. So when I'm solving for heat, I am doing Q equals mc delta T. So Q equals mc delta T. This delta means the change in temperature. So I'm going to set it up. Q equals the mass, which is 235 grams, times C. I'm looking for the C of water. Well, the C of water, this is a slide from the notes. And so this talks about heat capacity. Water has the highest specific heat capacity on the list. So here in my table, this shows the different heat capacities for different substances. So lead, gold, silver, copper, iron, all of these metals right here, these have low specific heat capacities. And what that means is that a substance with a lower heat capacity is less resistant to temperature changes. So that means it's going to feel the temperature change a lot faster, and it's going to change temperature a lot faster. So the greater your specific heat, the more energy it takes for you to change temperature. So if you think about when you're boiling water in a metal pot on your stove, what is going to get warmer faster, the metal pot or the water? The metal pot. And the reason why, it's probably made of one of these metals, and that's basically saying it takes 0.9 joules of energy to change the temperature of aluminum, but it takes 4 joules of energy to change the temperature of the water. So it takes almost 4 times the amount of energy to change the temperature of the water, and that's why the water doesn't heat up as fast, because it takes more energy to change the temperature. So a substance with a lower heat capacity is going to warm up quicker, and a substance with a greater heat capacity is going to warm up faster. So here's water's heat capacity, 4.184. So 4.184 joules per gram degree Celsius, and then times the change in temperature. So when you're doing the change in temperature, you're subtracting them. So the bigger from the smaller. So 100 degrees Celsius minus 25 degrees Celsius. So really I'm going to do 235 times 4.184 times 100 minus 25, which is 75. So then Q is going to be looks like we need 3 sig figs, so I would do, this is really 73,743 joules, and then I would change that to 73,700 joules. So that's how you solve for heat. Let's look at the next one. A 328 gram sample of water absorbs 5,780 joules of heat. Calculate the change in temperature. So I'm trying to find delta T. So if I go back, when I'm trying to find delta T, I'm doing Q over M times C. So let me write that equation down. Delta T equals Q divided by M times C. So they tell me Q is the joules, 5,780, divided by the mass. The mass of water is the 328, times the specific heat. So the specific heat of water, I go back to my chart, specific heat of water, 4.184. So I'm going to do 5,780 divided by 328 times 4.184. And when I do that with 3 sig figs again, I get 4.21 degrees Celsius. So we've solved for heat and we've solved for change in temperature. So let's do 2 more. This one says the temperature of a 95.4 gram piece of copper increases from 25 to 48 Celsius when the copper absorbs 849 joules of heat. What is the specific heat of the copper? Okay, so I'm solving for specific heat. So specific heat is Q divided by M times the change in temperature. So C equals Q divided M times the change in temperature. All right, so Q is the joules, so 849, divided by the mass, which is 95.4, times the change in temperature, so 48 minus 25. So really, 849 over 95.4 times 48 minus 25, which is 23. So 849 divided by 95.4 times 23 gets you a specific heat with, looks like 2 sig figs here, 0.39. And the units for specific heat, joules per gram degree Celsius. Okay, the last one we're going to do here is asking you to solve for water. So what mass of water? So mass is Q divided by C delta T. So mass equals Q, 525, divided by C. Again, it's water. So we're going to go back and we're going to use that 4.184. Times delta T, which they told us that the change of temperature was 3. So if there's only one temperature, you don't have to do any subtracting. So I'm going to do 525 divided by 4.184 times 3. And you end up with 1 sig fig. I don't want to use just one. So I'm going to say 41.8, and that's going to be in grams. So I've shown you how to solve for each type of problem here. So for heat, for mass, for specific heat, and temperature. Generally, the type of problems that you're going to do are going to ask you about specific heat of water. And we're going to want you to use a specific heat of water. And so the specific heat of water is this 4.184 joules per gram degree Celsius. And so then this is going to be basically your summary page for how to solve for different types of